So we are now doing calculus and now doing differentiation, or as you guys call it, derivatives. We are going to be deriving the formula. So with calculus, what happens is you are given an equation, f of x or y is equals to a certain function. If you have a function like this one, you see, y is equals to 2x cubed. So 2 represents what? The coefficient, right, of this variable, coefficient. So this is a coefficient, and 3 is the power of this variable here, this x. So this 3 represents n. So you have an equation here in the form of ax squared, ax to the power n, ax to the power n, that is the equation. So when we derive this, what you're gonna do is you're gonna write f, the derivative of x. So when you see this prime here, you see this one, this line here, it's like a small line at the top. It denotes that you are deriving, so it's f, the derivative of x, is equals to. So when you derive, you use what we call a power rule. How does the power rule work? With the power rule, what you do is when you derive, you take the exponent, you multiply it with the coefficient. See, a times n, so it's a times n in brackets, and then you write the variable x, and then at the power you're gonna say n minus 1, so you're gonna subtract 1 to that power there. In bracket you see n minus 1. Let's go about it again. When you derive, you take the coefficient, you multiply it with the exponent, a times n, then you write x, and then at the exponent you say n minus 1. So we have examples here. I've written 3 examples down. We're gonna use them to practice the application of this rule. So on the first example, you have y is equals to 2x cubed. So we have to derive this. So when you derive it, say y prime, so that it's a derivative, is equals to, so the rule says a times n, so it's going to be times 3. It's going to be 2 times 3, then I write x, and then we go to the exponent. It says n minus 1. The rule says n minus 1. What is n here? N is 3. Then we're going to say 3 minus 1. So the derivative here is equals to times 3 is what? 6x, and then 3 minus 1 is, so the derivative of 2x cubed is what? Is 6x squared. 6x squared. Let's use the black color. So let's go to the next example. So here we have f of x is equals to the square root of x cubed. So what I'm gonna do, from the laws of exponents, I'm gonna write this as a as a power. I'm gonna remove the square and write it as a power, as the fraction of that exponent there. Then I will convert that. Remember, from the rule I said, I told you guys that x, let me do this, to the power a over b is the same as b, is the same as b. This is b x to the power of a, you know. So when you have b outside x to the power a, you can write this as x to the power a over b. And we know a square means 2, right? So it means there's a 2 here. So we just don't put it normally because the term square already tells us that it's a 2. So I'm going to convert this into this form. It is given in this form. I'm going to convert it into this form. So applying this rule, then we will have what? F of x is equals to x, no, it's equals to 3 over 2. 3 over 2. See, the 1 on the square root comes the denominator here. B is the denominator. So now I have it like this with without the root. I removed the root. So now I can derive this. So when you do the derivative, it becomes f the derivative of x is equals to, so what is the coefficient here? The coefficient is 1 because see, when there's nothing, we know there's 1. So the rule says coefficient times n, so it's going to be 1 times 3 over 2 will become what? 3 over 2. Then you write x, and I write x, and then we go to the exponent. To the exponent we say what? N minus 1. So we're going to say 3 over 2 minus 1. We're going to write 3 over 2 minus 1. 3 over 2 minus 1, when you say 3 minus 2 over minus 1, you can write it on a calculator. 3 over 2 minus 1 is 0.5, because 3 over 2 is 1.5. So 1.5 minus 1, you remain with 0.5. 0.5 is half. So you can just punch that on a calculator. So here is, so here you have it. So if they say leave your answer in SAT form, meaning you have to take it back to the root. This is the derivative, this is the answer. So if you want to write it in the root form, it's going to be 3 over 2, and then because we have 2 here, it's going to be the root of x to the power 1, because the 2 comes outside and then the numerator remains, you know. But you know how it is, 1, even if we don't write it, we know 1 is 1, so we can just move it. So this is in SAT form. It's going to be 3 over 2 the root of x, same thing, because this half the square. All right, I hope you understand that. That is why when they say leave your answer in SAT form, meaning take it back to the root form. You derive it, come here. So the basic is you first have to remove the root, take it back to the power form, and then derive it. After deriving it, you can take it back to the root form if you have, if they want you there. Okay, here's another example. Let's go to this example. So with this example, you see that it's the numerator is quadratic and the denominator is linear. It's equation of the straight line. That one is equation of a parabola. So when you have something like this, what you have to do is try to factorize the top part. You try to factorize the top part and then see where it leads you. So we're gonna say y is equals to, okay, then I'm gonna factorize the top part. So when you factorize the top part, you know we're gonna have x, here, and then so the middle term is negative and this is negative, so it means the signs will be different. One will be positive, one will be negative, and then the factors of 3 that give you minus 1 is what is it. So it turns out I made a mistake. This should be 2, negative 2x here. Okay, so when we factorize that, you want the factors of 3 that can give you the middle term. So the factors of 3 that can give you the 2 is going to be 3 and 1. So when you say 3 times 1 you get 3, but when you say 3 minus 1 you get 2. that. And then the bigger term will take the sign of the middle term, -3 and +1, right? So there we go. So this is the factor we factorized at the top part, and at the bottom we have what? X minus 3. So you see similarities now. X minus 3, we have it at the top and at the bottom, you know. So because of that, we are allowed to remove it, they cancel out. So here you remain with what? You remain with y is equals to x plus 1. So x plus 1 is the function. So when you derive x plus 1, you're going to say y the derivative is equals to. So now here x is the same as 1x to the power 1. You get what I'm saying? So this x, let me write it here, is the same as 1x to the power 1. So when you derive this according to the rule a times n, you will say 1 times 1, and then you'll say x, and according to the rule you'll say n minus 1, then n is 1, so you'll say 1 minus 1 is equals to 1 minus 1 gives you what? 0, right? So this 1 times 1 is 1. So this is the same as 1 x to the power 0. So, and any number to the power 0, we know it's what? It's 1. So x to the power 0 is 1, because any number to the power 0 is 1. So in the end, it's just the same as 1 times 1, because x to the power 0 is 1. So 1 times 1 is just 1, right? So when you derive x, you remain with 1. Always, when you derive x to the power 1, the answer is just 1. And then when you derive a constant, then the derivative is 0, because there's no x here. No x, it's just a number. So when you derive a number, get 0. Remember that. So x, the derivative of x is 1, and the derivative of 1 here is 0. So your final answer, the derivative is equals to 1. There you go. I hope that makes sense, guys. So listen to it again. Try again. Listen to it and try again. Okay. Good. Okay, let us try something else. Let's try something else to confirm the understanding. Okay, so let's say we have I'll come back to this. Say e.g. 4. Let's say we have example 4. For example 4, we are given y is equals to 4x cubed minus x. It's machine saving minus x squared plus 2 all over 3x all over 3x. Sorry guys, I was going to write 3x. Okay, so let's say we have this one. So when you have this type, I can see that even if 3x is not a factor, you know, so even if I try to factorize here, I don't have x, or this is just a number, so there's no way I can factorize and get 3x outside, cancel this 3x from a number, you know. So what you do here, when you have something like this, you separate the terms first. What you can do, you're gonna separate the terms. Remember, b over a plus c over a can be written as b plus c all over a, because the denominators are the same, so you can combine the fractions. So this is what they did. They combined the fractions because the denominator was the same for all of them. So now we're gonna separate them. They gave it to us like this. We're gonna break it into quotients, different fractions like this, separate. So why? You don't derive it until you get to a point where it is simplified. You simplify it first before you can start to derive. So now I'm gonna break it. It's gonna be 4x cubed over 3x over 3x minus x squared over 3x plus 2 over 3x. So you see, we simplified it first. So now we see there are similarities there. There's x, there's x, there's x, there's x. So we're gonna simplify it even further, right? So this will be y is equals to so x by the laws of exponents, a to the power 2 over a to the power 1 is the same as a to the power 2 minus 1. So 2 minus 1 is just a. It means 1 cancels 1 to remain with 1, right? So here I have 1, 3 to the power 3x, x is to the power of 1, right? So this is 3, this is 1. So it's going to be 3 minus 1 is going to be 2. So you're going to remain with 4 over 3 multiplied by x to the power 2. I did this when I did the first lesson of laws of exponents. Please refer to it. Then minus, then this one. We know that when there's x, there's 1 before x, right? So this is the same as 1 over 3. And then we have x squared, we have x1 here, this is 1. So 2 minus 1 is just going to be 1, because 2 minus 1 is 1, so it's going to be 1. So it's 1 over 3 times x, then plus, so this one, so this is the same as 2 over 3 multiplied by 1 over x. So I'm separating them, because if you multiply 2 times 1 is 2, 3 times x is 3x, so I just broke it. And from the loss 1 over x, now I want to focus on this 1 over x. 1 over x. See, from the laws of exponents, we are taught that if you have a to the power negative 1 and you want to write it as a positive form, you just say 1 over, for 1 over a, then the power will become positive. If you have a to the power 3, negative 3, and you wanted to write it positive, the exponent in positive form, you just say 1 over a to the power 3, then the exponent becomes positive. The exponent becomes positive. So now if you are given this like this, positive like that, and you want to take it back to negative, it means you just have to remove that top part, and then the exponent will be negative. So now we have 1 over x, x to the power 1. 1 is positive. So if I want to write this as a negative form, I will remove that one. So it means we will remain with 2 over 3. And then I remove that one. Then I'll have x to the power negative 1. Because the power here was positive 1. So now I'm writing this power now as a negative form. I just removed that 1 at the top. So now this is 2 over 3 multiplied by x to the power negative 2 over 3 x to the power. It is in the form of ax to the power n. Remember the power rule. Allow me, but I don't want to raise here because I might refer to later. Remember the power rule says it first has to be in the form of ax to the power n. So it has to be ax to the power n. So this is ax to the power n. Ax to the power n, because n is 1 here. Ax to the power n, n is -1. But here it was not in that form, because you see it was ax to the power n over ax to the power n. It was dividing by another one. So we need it to be like this, simplify. So once it is like this, we can now derive, right? We can now derive. Now I can come and say y the derivative is equals to y the derivative is equals to, and then do that. So now the rule says what? An, or a times n, start by a times n. A times n, so it's going to be 4 over 3 times 2, right? 4 over 3 times 2. So okay, let me just write it down. 4 over 3 times 2, then it says x, and then after it says x, and then at the top it says n minus 1, so it's going to be minus 1. There we go. Then you say minus, then we come to the next one, we do the same thing. 1 over 3 times the power here is 1. It's going to be 1 over 3 times 1. Then you say x, and then you say n minus 1. N is 1 here, right? I see 1 minus 1. There we go. Then we do again for this one, plus there's some first one. So then this one is going to be 2 over 3 multiplied by n is -1, 1. Then I say x, then I say n minus 1. N is what? -1 minus 1. There we go. Then I will simplify that all. Okay. So now this one, 4 multiplied by 2 over 3, same as what? This is the same as 8 over 3. So this will be 8 over 3, and 2 minus 1 is just going to be 1. So x to the power 1. Yeah, it's 1, so I'm not going to write it. Minus 1 over 3 times 1 is what? Is 1 over 3. And x to the power 1 minus 1 is 0. X to the power 0 is 1. So that times 1 is just going to be that. Because this is going to be 1 minus 1 is 0. So it's going to be x to the power 0. What is x to the power 0? X to the power 0 is 1. Any number to the power 0 is 1. So we remain only what that times 1. So it's just going to be 1 over 3. And here I have 2 over 3 multiplied by -1. So it means we'll have what? -2 over 3. 2 over 3. Save it. Plus will be -2 over 3, over 3, and 2 over 3, then x to the power -1 minus 1. So -1 is going to be negative. So it's going to be x to the power -2. There we go. And this is the derivative. So this is the derivative. There we go. Right. So okay. So I derived it. See, that is the derivative. So I derived it, but look, I have a negative exponent. So if they say leave your answers in positive form, leave your exponents in positive form, then this is what you're gonna do. Up to now, the answer is correct. We derive. But if the rule the statement says leave on your question paper, the instruction says leave your exponent in positive form, then we're gonna have to write this as a positive, right? So to write this as a positive is just gonna be what? 1 over x to the power 2. What I was saying here. See, so if we have it like this, a to the power negative 1, to make it positive, we'll just say 1 over a to the power that exponent, but now it's going to be positive. So we'll only change this part. The rest are fine. We'll only change this part like that, right? Okay, so it's just going to be 8 over 3 x minus 1 over 3 minus 2 over 3 and multiply by 1 over x squared. And then look at this, 2 times 1 is 2, 3 times x squared is x squared. So meaning that I can group this. 2 times 1 is just 1. So I can just write this like that. So I can just do x squared. Group it after multiplication. I just multiply 2 times that 1 is 2. And then 3 multiplied by x squared is 3x squared. So it's 1 because it was a multiple. Or you can leave it like that. Either way, now the exponent is positive. I hope it makes sense, guys. And this is the answer as well. Alright, that is it, guys. That is it for when you are deriving this kind of equations. So let's go to the next one. Something else. Okay. So now we're gonna do derivative by first principle. First, we're gonna derive by first principle now, guys. And so the equations that we can solve by, or do I need to kind of principle? Okay. So oh, sorry guys. So I could show you where the formula was derived and how it was derived, guys, but that is at this point I don't think they will require you to prove that, you know. So I will show you the application instead, how to apply it. So the formula says y prime. Perhaps let me use a black color. Is y prime, or, you know, or f the derivative of x, like that, right? Is a derivative is equals to the limit of when h approaches 0 is f of x plus h minus f of x all over 8, right? So this is a gradient, guys. This is a gradient of a graph. If you have a graph and you have a coordinate here, the coordinate here is x, and the x it's x and f of x, because f of x represents y, right? So if you have x, then you'll have your y value is going to be the f of x. It's going to be the y value of x on that function. And then if you move a certain distance h, maybe you move a certain distance h, when you get here, the x value is now what? It's now the x that was here plus h. So the x value here will become what? Will become x plus h, because you were at x but you moved h. So you were at x here and then you moved h units, right? So when you get here, you are now at x plus h, right? That is the x value there, x plus h. And now when you are here, the y value also has changed. So here you were at x, you had the y value of x, So here we are at x plus h. Now we want the y value of what? Of x plus h. So x plus h. X plus h. So now if this is point A and this is point B, when you want to find the gradient, what do you do? The gradient, we know the gradient is going to be what? Changing y over changing x, right? So if you do the change in y, you'll say the y at b is f of x plus h. Then you say minus the change, right? Then the y at a, y at a is going to be f of x. Then the change of x, then is going to be the x at b is going to be x plus h minus the x at a is going to be x. So this x cancels this x, will remain with h. So you see this formula is the same formula we have here. So this shows that this is a gradient. So what they are doing is they are giving us this, but they are saying h approaches 0, meaning that this h is getting reduced. It moves back to 0. It's getting closer and closer to the point of A until it is on top of A, meaning point B is on top of A. Then h is 0. So it is approaching 0 like that. So we're going to calculate the gradient when h approaches 0, when point B goes back to point A, meaning that h is reduced until it gets to 0, approaches 0. I'm just doing this small summary here to show you where this formula is coming from, so that you can see the relationship. Right. All right. So when you have a function, say for example eg1, they say find the derivative of a function using first principle. They say y is equals to 4x, 4x. Let's say they give us this, or maybe let's do it like this. Okay, fine. Instead of saying 4x squared, let's say 2x squared. I want to show you something. Let's say y is equals to 2x squared. Okay, there we go. So they give us this, right? And they say derive this using first principle. So you want to derive this equation using first principle. Look, y, this is the same as f of x. They can write y, or they can write f of x is equals to 2x squared. Is the same thing, right? We know that. So what you do when you have this, you start first by deriving it. You derive it using the power rule. Then you leave that answer somewhere, because that answer is the one that is going to guide you when you use the first principle. Because a derivative is a derivative. Whether you derive using first principle or you derive using the power rule, the answer is going to be the same. A derivative is a derivative. So what I do is I derive it first using the power rule, and then I write that answer so that I know when I use the first principle, my answer should be exactly that. So 2x squared, when you derive it, it's going to be a times n is going to be 2 times 2 is going to be 4x, and then at the power is going to be n minus 1 is going to be 2 minus 1 is going to be 1. So now I know my answer, my final answer is going to be what? 4x to the power 1, which is just 4x. So now I'm going to derive 2x squared using the first principle, but I know the final answer is going to be 4x. I know the final answer is going to be 4x. I'm writing it somewhere so that I don't forget. Okay, there we go. So now we have it like that. So when you have it like that, you have f of x. F of x is this. So now you also have to write it as f of x plus h. F of x plus h. So it means when you see x, you just add h. F of x plus h is going to be f of x plus h. So this means where we had x, we just write that x as x plus h, but you put it in bracket 2, then bracket, because I see x, then I'm going to say x plus h, and close bracket, and then I write the square because the square was already there. There you go. See? So you see x, you change that x to x plus h because we've moved h distance like I've showed you on the graph. So it means the y value changes. It's no longer the y value for x, it's the y value of x plus h because we've moved h units horizontal. All right. So now we have f of x, we have f of x plus h. Then we can substitute on the formula. And substitute on the formula. So once you start by writing them like this, then you start to substitute. Okay, I will go to the formula. I'll say f derivative of x equals to, then sorry, I forgot to write lim h approaches 0. Then you start to write that f of x plus h is what? 2x plus h, like that. So this is 2 into x plus h all squared, then minus, then I write that f of x, but normally I put it in bracket x, but I put it in bracket because this is minus f of x, it minuses the whole thing. So if this had other terms, it was a long term plus what plus what or minus what. So this negative should apply to the whole thing. So I always good practice, put it in bracket so that you don't make mistakes even if it's a longer page. So you're gonna put the whole thing in bracket all over h. Okay, so let me move this side. So now I'm just gonna expand that. You have x plus h squared, you can expand it, you can do two factors, and then multiply everything. You do that the best way you know how to do it. That lim h approaches 0, so I expand that. It's going to be into x squared plus 2x h plus h squared minus x squared over h. Okay, and I'll continue. The lim when h approaches 0, I multiply everything by 2 now, so I'll have 2x squared plus 4x h plus 2h squared minus 2x squared all over h. Right, I have it like that. So now when I'm here, I start to see similarities. I have 2x squared and I have minus 2x squared, so they cancel out. I cancel them out. So what do I remain with on the next step? Writing x. So f of x equals to, when the limit approaches 0, h approaches 0, then here now I'm left with what? I'm left with 4x h plus 2h squared all over h. So from here I see I have h on this term, I have h on that term, so I can take 8 out as the common factor, right? So it's going to be the same thing. Limit when h approaches 0. So now I'm going to take h out as the common factor for h. So when you get here, you take h out as the common factor, then you make 4x here plus 2, and then here h was h squared, so now we're going to have 1h all over h. So you have h at the top, h at the bottom, they cancel out, right? You go. So the next step, because you don't have that, you are only left with one h, then h tends to 0. So f the derivative of x equals to, and now we have 4x, we have 4x plus 2 into h tends to 0. H tends to 0. So 2 times 0 is what? Is 0. So this whole part will be 0. Therefore, f the derivative of x is equals to 4x. 4x, because 2 times 0 is 0. So now we have to see, is this answer correct? This answer correct? We compare it with the one that we got when we used power rule. So power rule gave us what? It said that the exponent, the derivative of 2x squared is what? Is 4x. So here we had to find 4x. So the answer is 4x, and which means it is correct, because it's the same. So see, I was solving, but I knew what the answer had to be. It makes life easy because you know if you are correct or not. If the answer was different, I was gonna go back and check where I made a mistake, because I know what the answer should be. So let us go back to it and see what are the steps. So you get f of x, the given f of x equals to expect. So the first thing you do, you write down, and you write a f of x plus h, because this is the second point, f of x plus h. Where you see x, you write x plus h in bracket, x plus h. You see it was x here, so now we change to x plus h. I put it in bracket, and then I put that square outside there. Then you go to the formula, you substitute. So when I substitute to the formula, f of x plus h is this one that I just did, minus f of x. So f of x, you put it in bracket as well. Put it in brackets, because sometimes it can be a long formula. There's 2x squared plus what minus what. So you put it in bracket, because this negative has to be multiplied with everything, every term of f of x. So you put f of x in brackets so that this negative can multiply everything out. Then you expand and you simplify, and simplify further until you are left with h there, and then h tends to 0. Then get the final answer, the derivative. These are the steps. It doesn't matter how it comes, you just do it like that. If it was a surd, if they give you something like the square root or whatever, you know the rule. You first have to write it in the form of ax to the power n. So you change it from the square root, you change it from the root to the power. And if it was 1 over what squared, the positive power, you change it to a negative power first, so that you can be able to work with it. As long as you follow the rules, you will be fine. As long as you follow the rules, you will be fine. So what I'm saying is, even if it comes like this, if it comes like this, you would first do it like this, and then you have f of, sorry, you first write it like this and have your f of x like this, then you do your f of x plus h. And if it comes like this, you first write it like this, then once you have it like this, then you'll write f of x plus h. No, so it doesn't really matter how it comes, as long as you follow the correct steps, then you will be fine.